You guys have been here for quite some time. Before we get started, how is everyone feeling out there? Are you exhausted? Excited?
Yeah.
What's the feelings?
All the above.
All the above?
Yeah.
I'll take that. Anybody just feeling like, holy shenanigans, is it almost done? Like, is there a finish line? Is it coming soon? What's everyone's thoughts right now? Someone
Can't
talk to
wait
me.
for the finish line.
Can't wait for the finish line. There you go. Anybody out there just like super stoked, like let's just keep going, like still got energy, like I'm back in the 21-year-old day era? Anybody? There actually might be 21-year-olds out there. I forgot about that. 21's not even young sometimes. I missed my energy when I was like 12 or 13. Just like keep running for days. All right. All right. Well, I hope you all are feeling a little bit better. Oh, let me go ahead and just get that. There we go. Perfect. I'm recording, right? Did you guys hear that? Yeah, I'm recording. There we go. Good. Put you down there. Okay. Welcome everyone to another lecture with yours truly, Kyle. I hope you all, even though it didn't sound like too much happiness out there, keep it engaged, keep it up. You guys are almost to that finish line. It is right around the corner. I know you can't see it yet. Cuts around the bend, but we're almost there. We're almost there. Let's go hop into some things first. Let's go talk about some announcements. Today, we're going to be going over exceptions, Java exceptions, as you probably already know. Let's talk about those announcements. As you also probably already know, assignment number 3 is coming your way. So just getting ready for all of that. I'm going to go and turn on live transcripts here too. There we go. So assignment number 3 is right around the bend. So making sure that you're at least reading that, getting assignment number 2 all finished. Hopefully everyone is done with assignment 1 or getting there to assignment 2 and feeling comfortable about those concepts. That was the base underlying architecture of Java. So the basics of Java was number 1. We built on those basics in assignment number 2. So those two concepts combined is really the essentials of Java and what every Java application is built upon. Now we're clearly learning a little bit more new technology, that Spring Boot and some other things coming down the line to do more with Java and take it beyond what it typically was prepared for. That's what's going to be in assignment number 3. So everyone's feeling good about that. As a little present to everybody, if it is kind of technically a present, I'm going to be doing open office hours tomorrow. I have not talked to you guys one-on-one a lot here, and I really want to try to open up my time a little bit more. So I'm going to have open office hours tomorrow from 3:30 p.m. to 4:30 p.m. If anyone wants to bring questions, concerns, comments, anything they want, to bring them in. I'm happy to talk through any kind of problems that you're having with technology. If you're wanting to talk about what's in the future with launch code, not necessarily liftoff, but anything that's coming down the line, whatever you want to talk about, I will be an open book tomorrow from 3:30 p.m. to 4:30 p.m. But then that book closes right at 4:30. Not really. Of course, I'll always answer your questions. Direct message me if you don't want to do the office hours or these times don't work for you, and we'll set up that one-on-one time. Or you can just go directly to Calendly. Finally, though it might not be clear on the website, please make sure that you go to your small groups tonight. There is still going to be a studio. So please go to that studio, make sure that you're in those small groups because they will be taking attendance. All right, any questions at all from you all? Anything at all? Oops, thank you, Kevin. I got that transcripts. All right, any questions at all? Anything? Talk to me. No? All right. All right, so today is kind of about exceptions and Java tooling and things like that. The thing is, though, you already kind of know about the exceptions and you know about the tooling. So I want to take this moment just to really elaborate with all of you where you truly are at. You right now are almost to the end, at least halfway through Unit 2. You completed all of Unit 1. You know JavaScript and you know Java. You probably at this point are feeling a little exhausted. You have done a ton of work to be up into this point. So what I'm trying to get at is that really trying to thank you all for staying with this, staying in it, and staying engaged as we've moved through this class. Basically what we're working towards is to be a developer to be a developer in corporate. And basically you're putting all this effort into it. So as we move forward, we're going to keep continuing to prepare you for that just until you get into liftoff, and liftoff will be preparing you even more. So when I get to this point, I get a lot of questions typically from different students, or even anybody when I was a mentor, is about what is actually the work life of a coder. So essentially, what do you have to look forward to when you get out of the class life and into work life? Because they are a little different. So we're going to talk about that. Work life as a coder, basically, as you have already probably seen in a lot of movies, our formal attire back in the day when we were actually in the office was very formal, or a very like a very relaxed, casual attire. Same like what I'm wearing now with a t-shirt, sometimes even shorts or just pants. So very, very optional and formal attire. Everyone's very laid back in the environment and focused on sharing ideas, that collaboration. Collaboration is absolutely key in the coding community. As you've already probably seen on Stack Overflow or wherever you try to search for your problems, collaboration is a main thing in the community. And everyone is always trying to share ideas. Coders are very, very talkative via those kinds of channels and trying to help other people out with fixing their problems, and also taking those fixes and making better applications out of them. To continue on that, a true push to continue learning. As you know, technology is always changing. It's always upgrading and turning into different things. So in these communities, you're continuously pushed to learn those new technologies, to bring those into your applications and better them for the environment that you're working in. And then finally, as the developer, though sometimes TV portrays a developer as a heads down, someone who's just drinking Mountain Dew and eating chips all day and doesn't talk to anybody, is not very true in the sense of how the coding community has transformed. Now, coding communities are usually small teams and very hyper collaborative, meaning we're always sharing ideas. I'm in constant communication with my teams, even online, because we're constantly mobbing or working with each other to create one application that we share. So it is very, very collaborative, and even more so now that a lot of things is virtual. So you're constantly expecting to contribute and talk to each other. So let's exactly take what this work life is and bring it into how it fits into this class life that you've been talking about. As of right now, you all have been taking on your own personal applications. You've been doing your own assignments. You've been doing your own studios, your own exercises. You've been working on those individual projects. So you're putting them together however fast or however slow that you want. You're basically on your own timeline. And as of right now, that's completely fine. As long as it matches up to the timeline of launch code and getting those assignments in on time, you can work as fast or as slow as you want. But that's class life. We're going to take a close look now at work life. Basically, teams, as I said, teams of maybe 3 developers, 4 developers, 8 developers, regardless, there are more than one on that team, and they work together to create the applications. And these individual coders are all contributing. But say you have an individual on the team that doesn't technically provide their area of the application as fast as the others, or goes slow or something along those lines, and basically not matching up to the same timeline. The other team members start to feel that. So that's where timeline truly comes into this collaborative work of coding. So we work together to make this application, and we all have to work on the same exact timeline. So you can only do this if the team is feeling that, and I hate this word, but feeling that synergy synced up, essentially making the application and communicating where they are at all times, and sometimes working together to catch another individual up. So this is work life. So our class life, we're working on our own timelines. With work life, we're bringing in other people in their times, and we have to respect that. So where am I getting at with this? Bringing work life and our class life together, we need to find a way we essentially blend it together. And how we do that is we make sure that in our class life right now, we are doing our timely contributions, since that is the main expectation of a developer. So making sure that we are getting those assignments in on time. So basically, as we go with assignment 1 and assignment 2, making sure that we are getting those finished, as well as assignment 3, making sure we get that 3rd assignment in on time so we're ready for assignment number 4. Because in the work life, tasks never stop. There's always a workload coming down the pipeline. And therefore, we always have to be ready and finish our work on time so that stuff doesn't get backed up and eyes don't start appearing on us as the team. since everyone is responsible for how the team looks in a corporate atmosphere. So that being the case, what if, for whatever reason, you're feeling that, or any individual on a team is feeling that they can't contribute in a timely manner? That's because in those things, or in those kinds of situations, we are met with a problem on that timeline that maybe we are not able to accomplish. If we're stuck with this problem, essentially some kind of question, some kind of knowledge gap, we know at least one thing. If we have a problem, that we also have a question. If you have a problem, you have a question that you need to develop. That is the main part of the development process. Give me 1 second. There we go. So when that happens, when you have that knowledge gap and you know you have a question, but maybe you aren't able to frame it in the right state of mind or to communicate to another developer or even onto Googling what that problem is, we need to be able to become our own investigator. And that's how our work life and our class life can really combine into one. With our personal applications or even with our work applications, we will come across these obstacles and we will need to be able to figure out how we're able to properly frame our question. Now, when we first started in Unit 1, or even now, you might hear the questions of, my code is broke, something is wrong with my application, I can't figure out what's wrong. These are all correct. Do you have an issue? But this isn't how you ask a question. Essentially, when you're a developer, we have to go into a more granular level. We have to dig a little bit deeper into our questions. We have to become that investigator. So before you ask a question to either Google or to another colleague, question yourself. Essentially, what you want to do is that if you have a problem, you know one thing at least, especially in Java, you can click that green button. And sometimes it works and sometimes it doesn't. So the first question you can ask yourself is, can I compile my application? You have a yes or no answer to this. It's a 50-50. Can you or can you not compile your, can you or can you not compile your application? AKA, is there an error in the terminal or is there an error in, will I compile? So basically, can I run my application but it breaks when I'm at a certain point, or does it not even run at all? Let's say in this case, I can't even compile my application. Then I ask myself, okay, is there an error in the terminal? Yep, there's an error in the terminal. All right, well, what does it say? It says unidentified or identifier expected or something like that. So we're just looking at this kind, you've seen many of these errors. You'll see kind of glimpses of words in those errors. And that gives you more clues essentially to what the problem is in your application. So maybe you can keep asking yourself, when was the last time I compiled it correctly? When did my application work? Did it ever work? Did it work just yesterday or something like that? So maybe if it was just working yesterday, something must have changed between when it was working and when you weren't. So you ask yourself, what have I changed since then? Make sure that you remember how it was working and those baby steps you got to get to that error. Maybe you have some significant event that happens. Say your cat sat on your keyboard and you're going to look more into it. At that point, you're going to have to go back and look at your code and see maybe where are the red lines at? What exactly happened in which file? Maybe I have to switch something around. Essentially, what you come across here is the set of questions to get yourself to formulate a question for either someone who's trying to help you, such as a TATF, another colleague, or even if you're just trying to Google something. Good questions make for the best answers, especially in the development world. So before you ask your question yourself. Ask your questions and formulate something that you can ask somebody else or Google or search for easily. So with that example we just saw, I can say at least, hey, I'm getting an identifier expected error in my code. Do you know the typical reason for this error? This is a way you can formulate a question to somebody that can give them enough detail to give you back a very specific, or at least a better answer than following up with more questions to get to a certain point that will actually help you. So what it is that you need to ask those questions to investigate your own errors, to figure out at least as many clues as you possibly can, and then ask Google or ask another individual to assist you with that. This is exactly how the, the coding process will work in the work-life balance or even your personal applications. So what I would just want to go over there is essentially the start of formulating those questions to do that debugging basically manually to help you out a little bit. So look at one more example here. Can I compile my application? Let's bring that back. Just kind of the typical coding structure we're doing. Yes, I can compile my application. Is there an error when I compile? Yes, there is. All right, we know something. We know I can compile, but there's an error somewhere in there. When this happens, we're going to something very specific. What happens here is called an exception. So basically, we asked our questions, we saw that there's an error in the compilation, meaning that our program was running, and then something happened. This is called an exception. Before I move on here a little bit further, I see a question about average, how often do we run into trolls or naysayers, people that put others down, hoping that it's not too often, but I understand the internet, hide behind being anonymous. Typically in the coding community, if you're putting out questions like that, at least in my experience, you will see maybe 0.1% ever of a naysayer or a negative Nancy out there, essentially. So why that is one, there's a lot of admins, especially on Stack Overflow, that are removing those negative comments that are not helpful to anybody. And two, the coding community is typically very uplifting. Everyone out there, including yourselves, are trying to build something. So they'll usually add upon that and try to help you as much as possible. People from all around the world will try to help you to get across that question. The one thing that they will be a naysayer about is if you try to put homework questions out on Stack Overflow for coding. A lot of developers out there can really smell when it's more of a lecture question or if it's more of a quiz question, and they'll say that they're not going to help you because you need to do it yourself. That'd be the closest I've ever seen to a naysayer. Yeah, absolutely. The coding community is probably one of the most, like I said, collaborative, inviting people that are just trying to better themselves in this art and to really build something and better their environment or better the world through it. So no, very, very, very cool people. Of course, I won't like deny the fact that there's trolls out there, negative people, but I have not run into too many. I'm gonna pause it right here. Any other questions about what we've gone over? I've been chatting a lot. So anything about just the debugging process, asking those questions, being your own investigator, anything at all? I know it's a very off-topic thing, and like, why is Kyle even talking about it? But honestly, this is one of the more important things to talk about right now in your development cycle before you actually get into that liftoff project, is really just remember to formulate those questions, becoming your own debugger, and then only relying on colleagues, TAs, TS when you truly have that knowledge gap or you have some kind of obstacle there. But when you come across that obstacle, making sure that you have all the necessary components to ask your question and formulate a discussion about it rather than just throwing out a please help me. Because you're better than that. You have the knowledge, you have the know-how. You're here halfway through Unit 2 to actually provide that clarity and understanding, at least in a small regard, at the bare minimum, about your problem. All right. If there's no other questions, I'm going to keep moving on. All right. Oh, and I didn't even allow you guys to unmute yourself. You feel free to unmute yourself too if you have any questions. Sorry, I didn't see anybody type in there. Thought I'm letting you unmute. Anything at all? 3, 2, 1. All right. Let's keep moving forward. Let's bring it back to this exception thing. You've seen exceptions before. If you haven't, you are a lucky individual. Exceptions are the things that cause bad Mondays. As it's a Monday, look at that. Let's talk about these things. Let's explain the unexpected. Let's talk about these exceptions and things that you've probably seen before. Look at this little guy. String, my null, variable equals null, just minding their own business. How could this ever hurt you? Until the next line, you're like, why don't we just try to do this to a toString here? You know what happens? The world explodes. That's not cool. You have a null and you try to do a toString. When this occurs, your code will break. It will stop right there. It will execute. It will do an exit one. An exit one means that The world in its eyes has ended. Nuclear blast zone, bad. Specifically though, to you, you need to know, why did the world explode? Yeah, an exception occurred, but what kind of exception actually happened there? And that will point you more towards those answers to your problem. In this case, it was a null pointer exception. Null pointer exception means you tried to do something fancy on a null, but we know null is a black hole. It's nothingness. It doesn't have a toString method. It doesn't have any methods attached to it. So we can't do that. So that is that exception. We're going to go and just take a look at it right here, just so we can all see what it truly looks like in IntelliJ. And what do we call that? My null variable equals null. And all we did was my null variable dot toString here. Look at that. And IntelliJ even is like, oh yeah, you can do that. Absolutely. I'll even help you out. I'll let you type it. I'll type it for you. Let's go ahead and run this and see what happens. So as we run this, everyone's probably most favorite thing they've ever seen is a bunch of red in their console right there after they run their application. Exception in thread main java.lang null pointer exception at program.main. You've seen this before, and we're going to break it down just as we always do here. Exception, that's that word. The world blew up. In thread main, don't worry about the thread main. That's just telling you where it is in the application. And it tells you right here, java.lang null pointer exception. Okay, this just gave me some details. We just got the sweet deets right there. This thing is spilling a tea. By the way, I'm learning all these things from the show I'm watching, like what all the whippersnappers are saying now. Spilled the tea? I don't even know where that came from. But anyway, spilled the tea here, null pointer exception. At program.main, program.java 6. We just got a ton of information from just 2 lines of code. We know that something's wrong with null here. In my program.main, aka program, the class name in the main method, at line 6, it told me exactly where to look. Kyle, you messed up. You are having a bad Monday because you typed something wrong right there at line 6 in the program class at the method main. To Gracie, the show I'm watching, which I'm kind of embarrassed to say, is called The Circle on Netflix, and it is hilarious. I don't know why I find it hilarious, but it is funny, and I'm learning so many hashtags. Don't shake your head at me, Eva. I saw that. I love that, all right? It is a good show, right? I'm learning how to do all the emojis and stuff. All right, let's bring it back. I'll try to throw out some more. So what we were trying to see here is from this exception, we got a lot of information. In AK, we're able to formulate our questions to ourselves or to others or to Google just from those 2 lines. Now, are we gonna get this right off the bat? Absolutely not. Of course, from practice and from our wisdom that we're building upon getting these errors, it gets a little bit faster, but at least we can learn just from those small little things. Diana the whippersnapper comment. All right, let's keep looking at things. Look at this one. Another little string comes in. My string, not a number. What's gonna happen here? All right, int num integer.parseInt. Can anyone guess what's gonna happen? Yeah, that's right. World explodes. Boom, once again, and boom goes the dynamite. Exception, number format exception. We knew something went wrong, but we get a little bit more detail. This number format exception error. Let's see this guy in action. This is gonna come when we're parsing things. So string my string equals not a number. And then we've also seen this in one of our lectures, I believe, before, but it never hurts to see it again in the wild. Parse int, there we go. My string, just like that. Go and run this. Can anyone just like hear the bomb ticking in the back? Like, oh, there it is, boom. All right, let's see this one. This is a little bit bigger than our null pointer exception. It said null pointer, if it still has our lang number format exception right there for input string, not a number. It even gives us a little bit more detail. It tells us what our string actually was when we were trying to format it into a number. And then of course, it tells us all of this stuff right here. But take a very close look here. We have 3 lines of stuff that is trying to confuse you. This number format exception for input string, it gives us this thing, and then integer.java at this random line and this one. These are just different libraries that your parser works with. We don't even care about that. We can't even recognize any of those file names. We don't have a number format exception.java in our application. That's why we come down here. I see program. I can recognize program. I know I have a file there. So that's why I can just recognize I don't care about any of these guys. I care about this one. This is telling me on program.java in my main method on line 9, I have an error. Line 9. So it's that small little thing about working around the junk email, basically. This would be the junk email right here. And trying to find the true gems to help you investigate your problem. That is debugging on a manual scale right there. All right, let's keep going. Let's take a look at one more. Let's bring in this nice, fun array. Nothing's wrong with this. It's just a nice, calm array. Nothing to hurt. It's not going to hurt anybody. And you might have, there we go. Int bad idea array at 200. I want the 200th index of an array of just size 3. What happens there? You know what happens. Not a good day. Boom, right? This right here is another exception. Array out of bounds exception. Basically, it's just telling us that we are trying to get an index of an array that is way out of bounds. You're trying to ask for an address that does not exist. What are you even doing? It's like asking for the 13th egg and a dozen of eggs. Why are you even asking about that? That's weird. No one even says 13th egg, so probably a bad example, but you get what I'm talking about. You're trying to access something outside of that array, does not work, gives us an exception. What we can see from each of these examples is that they're all exceptions, but the names of them pinpoint what exactly is going on in our application. Sean, technically true. Buy a baker dozen of eggs. I accept that. I accept that. But this is where we're coming from. When you're trying to debug your errors, when you're trying to come across what the true problem is, look at the name of the exception. It will give you those hints. It will give you those clues. Try to figure out that puzzle of why am I getting a null pointer? Why am I getting number format? And where the heck am I trying to get out of bounds of my index array? That will give you a small hint. But the typical next question inside of there is, okay, where is this array even at? When am I trying to even like out? I have like 18 arrays, Java, like which one am I trying to access? And again, when you come across that next question, you look for that line that code is on. So not only do you know that you have reached out of bounds of an index of an array, but now you know the line of the array that it's at. A typical question after that is like, okay, I know where it's at, I know what I'm doing, but I have no idea why this is happening. I just did this yesterday and it works, and what's going on now? The next step after that is to start system.out.printing things to the screen. See what's going on. What is actually the problem? It's basically like opening up the hood of your car. You need to see what's going on, and it gives you more understanding about the problem. So print out that index. What are you trying to access? What are you trying to maybe parse into an int? See it, because that will give you a third clue there to ask that. And like, hey, buddy, I am getting a index out of bounds exception at this line, and I see the array that it's working on, and I have this printout, but I have zero idea what's going on beyond that. What you just brought to that individual is a very good starting point to help you out. They can at least at that point visualize kind of what's going on and maybe come up with some kind of solution, or at least ask to see the code. Ryan, we can go over a quick of the IDE debugger here at the very end. Yeah, we can definitely do that. We'll take a quick little glimpse through it. We're gonna have some time. So good call out. I'll do that at the very end. So that's what we're getting at, is that doing that. So, and also to get more clues, we'll go over that visual debugger and see it in action as well here in a second. Before we do that, let's go ahead and do one more here. Let's talk about this one. Pet, my pet equals new dog. We've seen this, the pet class. We are trying to do the dog class that is a child of the parent, or of the parent pet class. But this is what we also saw. Cat, my cat equals cat, my pet. We know my pet is a dog inside of there. We're trying to cast it to a pet, or to a cat. In this case, of course, it's going to blow up. This right here is called a class cast exception. If you are wondering why you got a class cast exception, it's because you were trying to cast a dog to a cat. Something that is not it to something else. You're trying to change the object into something else, and that is not allowed. You're casting it to the wrong thing. Look at this one now. Please pass me a dog, new cat, LOL, nope. In this one, we are doing the public void, please pass me a dog, and we're taking that pet. What we want to do is we put in that dog object, dog equals, or dog, my dog equals, we're casting that dog to a pet. From this one, what's happening is that we are passing in a new cat into this please pass me a dog method and trying to cast it to a dog. As we just saw in our class cast exception, do you think this is going to work? No, in this case, we are going to blow up because we're trying to cast a cat to a dog. They don't like that. They don't really typically get along. So we're not able to do that. So in this case, if this is inevitable, because you never know if cats are going to come down that chute into the please pass me a dog method, it can't always be promised. So how do we actually protect ourselves against any of this? You've seen this concept in JavaScript and how we protect this ourselves from these kinds of problems that might have situations attached to them. So we use a thing called the try catch, where we use that keyword try and we wrap it around the code that we want to protect. Basically, try it out. And if anything goes wrong, we do a catch statement using that keyword catch. Inside of here is basically the specific exception that you're looking for. You just learned 4 to 5 different exceptions. We can look for all of those specifically. So in here we say class cast exception in that EX. And if I get this, I'm going to say, oh, that was not a dog. And I'm going to print that back out. And basically this output would be, oh, that was not a dog. Let's go ahead and see that in action. In this case, we do not have cats and dogs, but we do have cake and cheesecake. So I'm going to say public static void, please pass me a dog. I'm going to say, please pass me a cheesecake. Because heck yeah, I love a cheesecake right now. All right, like we said, we are going to try to do cheesecake. My cake equals cheesecake. Oh, what I want to do also is make that the more generic one. There we go. So we're passing the more generic, the parent class. And as we remember, if we go into cheesecake, it is going to extend cake. And so does chocolate cake. It extends cake in this example. So we have cake, and then it extends to cheesecake, and then chocolate cake. So we can go back to program. Mark, we'll go ahead and dive into that. That's just short for exception, though. It's the variable name for the exception itself. Great question. All right. Let's go ahead and make a cake. So we're going to say chocolate cake. Choco cake, there we go. Let's need a chocolate cake. I forgot what I even needed in there. And what we're going to do is pass that into please pass me a cheesecake. Pass in chocolate cake. Let's go and see what happens here. Let's run that. And we see it exactly what I promised you. We get that class cast exception. So I'm going to unmute you. Tell me now, we are getting this class cast exception. What do I need to do to protect myself against this? What keywords are we going to try? What keywords are we going to use? Feel free to unmute yourself if you know the answer. Oh my gosh, I'm backwards today. Please now feel free to
try.
Try.
Thank you. I'm like, everyone just does not.
I'm doing sign language. You don't understand.
I see it. Awesome. Well, we're gonna do try. Thank you. At
First
least you're like,
Facebook
totally.
down and now Kyle. All right.
Right? All right, so we wrap try around the code that we want to actually try that might have errors in it. But what do we do after the try? What do we attach to it?
Catch exception.
Catch.
We do catch. Very good. In this case, we're going to look for a specific exception. In this case, it's the class cast exception. I put EX there. The question was, again, in chat was, what is this EX? Remember, this is just an arbitrary name. In this case, you'll typically see EX. It's short for exception. I can call it whatever I want, though. It's, again, a variable name that you choose arbitrarily, just like how you do it up here in your parameters. I do like to put EX there just because of my OCD. Let me say system out dot print line and say, that was not a cheesecake, but thank you. Because I mean, if they're gonna give me a chocolate cake anyway, I'm totally gonna do that. Eat whatever cake given to me. All right, we run this and now let's see what the true output is. Now we get a system out saying, oh, that was not a cheesecake, but thank you. It's because we do that try catch, so it protects us against exceptions. Now take a pause here. This is very powerful and will protect you against errors. But if you overuse a try catch, you can also hurt yourself. If there is a true error out there that is causing your application harm, a try catch will technically silence it in its regard. So make sure that you do not overuse try catch. Only use it on things that you truly know that need to be protected. Those things can usually be casts, but making sure that you're handling those exceptions, knowing somehow something's not being casted right. Do not overuse try catches. With great power comes great responsibility. I'm just gonna make quotes all day. I'm gonna do. So remember that. Give me an example of overusing it. How can it be bad? So if you overuse it, AKA if I wrap everything in my application with a try catch, that is overusing it. If I wrap very important heavy lifting algorithms in a try catch that have nothing to do with casting or anything that has certain dangers to it, that is overusing it. Using it on casting members or small areas of my code that I know could be error prone, that is the true way to use them. How do I know if it's error prone? You'll slowly begin to notice things that are more error prone than others. Why I keep bringing into it is the casting is typically the most error prone stuff. Sometimes things get passed into methods that shouldn't have been, so we have that inheritance going on. Try catches are there to protect you. Another big one is networking. When you're waiting for somebody to talk back to you on one of those fetches, but in Java sense, a try catch can also be helpful with networking stuff. It's another popular way of using them. But overusing it is using it when you know you don't have to. So if you don't think you need it, you probably don't. It's better to unuse them than overuse them. Andrew, does that help?
Yes, sir.
Awesome, awesome. All right. So let's go ahead and keep talking about, where'd you go? This try catch that we just did here. So we have the please pass me a dog. We have that try catch in there. And on our actual code base, we have that please pass me a dog, but we're still passing them a cat. Again, try catches will hide our errors. They'll hide our exceptions. And we don't always want that. Maybe we want things to tell us that things are going wrong, but we're going to handle them. Exceptions, unhandled exceptions are dangerous. Handled exceptions are a-okay. If you're handling your mess, that's fine. If you're just letting that mess run rampant, that's bad. Hence why we can handle our errors in a certain way. And how we can do that is that we can throw our errors to the next method in a more controlled sense by using the word throw. To throw an exception, we have to build an exception. So we say new exception, and then, yo, that's not a dog. What we just did is handled our exception, changed it to what actually the error is, and passed it back to our method. Passed it back to the please pass me a dog. Throw works just like a return, but instead of returning some kind of data type, you're returning an exception. It will leave right after that line. It will not continue to run past that throw. Let's go and see that in action. So instead of the system.out, where I was not handling the exception, instead I just printed something out to the console, I now want to tell my user what the actual problem is. So what keyword do I use to handle my exceptions?
Throw.
Throw, very good. New exception. We're going to build a generic exception. Say, yo, give me that cheesecake. There we go. I'm going to run that. And what do we have in there? Oh, semicolon, Kyle. There we go. And run that. And oh, I got to do one more thing here. Yeah, there we go. If you throw an exception outside of a method, you need to let your other methods know that and say throws exception. This will tell your other methods that you have the potential of throwing an exception back at them. Meaning that there's something crazy going on in your method and be protected against it. AKA now this says unhandled exception and it knows you're probably going to throw one. So what you do up here then is you would call or you place this also in a try catch. And this is how you handle those problems. And then something went wrong. And what I can do is I can say ex.getMessage, aka what the message actually is inside of the exception. So what did I just do here? I placed a try catch around this please pass me a cheesecake method because it throws an exception. We needed to handle the exception that's thrown. Again, we got to control our mess. So what we did is that we put in this catch exception ex. You might be asking yourself, what is exception? It's the generic class for all exceptions. It's the class that all exceptions stem from. Class cast exception stems or is the child of exception. So is the parsing one, so is the null pointer exception, so is the index out of bounds. Everybody's a child of the exception class, meaning that we can catch all of those, no matter what exception is, we can catch it by putting it just like that inside of this catch expression here. So let's go and run this and see what happens. We should still get that error. And we did. Something went wrong. Give me that cheesecake. Perfect. That's because we are system out printing our message to them and getting that ex.get message, aka the exception up here and the get message that is inside of it. Now, this is a lot. I guess the question is, are you only ever handling for one type of exception? Technically, you can. When you don't exactly know what exception is going to come back, aka you don't know if it's going to be index out of bounds, you don't know if it's going to be casting, you can use the exception to generally catch all of them. So this is basically a catch-all catch statement, if you will. So yes, you are typically, you can typically be looking for more than one exception because an index out of bounds exception and a casting exception can happen in the same algorithm. Anything wrong can anything can go wrong in that algorithm. So yeah, it's typically better to use the more general one unless you need to go by a case-by-case basis. For anybody who wants to know out there, for a case-by-case basis, what you can do, say catch, and you can say the class cast exception here. And then you gotta name it something different. So I say CEX, just like that. And then now you can do something case by case. If anyone wants to dive a little bit deeper into exceptions. There we go. Something went wrong. Oh, when did you catch that specifically? Oh, because I'm throwing a generic exception. Duh. There we go. Let's go ahead and we build a new one there. There we go. Casting went wrong. Give me some of that cheesecake. That's how we know that this one got executed. There we go. So there's a little bit of deeper dive into there. Any questions about the throwing or handling on that part? I know we went a little deep in there.
I have something to say though.
Yeah, Amy, what's up?
Right now there is a situation that's going on with the developmental disability and intellectual disability community that is kind of sensitive right now to us. So the term execution can be kind of triggering right now with that situation with that boy.
Okay, well, I apologize. I'll try to keep it from using that word then.
Okay, thank you.
Absolutely. All right. So that is basically how all of this is used. So if anybody has any other questions about any of the exceptions, anything at all, any of the specific cases. All right. Cool. And that, basically, like we said, there's an exception. We already put that there. Let's see what else I got in this guy. Yes, it always passes back. We'll have the output. Yes, and we wrapped in that try catch. Awesome. And we put that generic exception in there. And then we do the get message. Awesome. All right. And then our output was not a dog. There we go. So that is all I had for that, but we're not done. We're going to go ahead and go through the manual debugger real quick just to see exactly how we can use that and how you all can use that as you're going through your assignment 3, 2, or 1, or 4, or Studio 19. Okay. If anyone's ever asking what is a debugger, I always ask that myself that until I actually had to like look at the words like, okay, I get it. You're debugging your application. Like, okay, that makes sense. So you're trying to get rid of all the bugs, AKA the debugger in the IntelliJ is going to be this icon with the bug here. So how do we actually use that? Well, remember our code goes sequentially. It goes line by line. I promise I haven't lied up until that point. It always goes sequentially. Of course, we skip around when methods come into play, but we're still going line by line, even if we're going to different lines and going down from there. Where am I going with this? Is that we can place debugging breakpoints on specific lines of code. So when it does get to that line, we can stop there and take a breath and look at what the application is thinking. Let's see what I mean by that. What if I wanted to just pause my application if this application gets thrown or this section gets thrown? I just want to pause there and be like, okay, why did my exception actually get triggered? So what I did was I just clicked here next to the 26. I did a single click and it made this red dot. If you're ever wondering why you had a red dot beforehand, when you click there, that's what these are. It's called a breakpoint. What we do then is after we set a breakpoint, which you can set as many as you want, you can set another one right here. You can set the whole thing to breakpoints if you wanted to, and click the bug. What it's going to do is that it's going to start running in debugging mode. And it's going to run your application just like it always does. But if it hits one of those breakpoints, it's going to stop the application. So right here, we saw that it stopped at this throw new class cast exception. We know it was going to stop here too, because we're passing in a chocolate cake into that exception. So there we go. We're going to go ahead now, and so we're paused here. We know it's paused because our debugging window on the bottom just opened up. So what we can do is we can resume the program with this icon up here, which means we just keep going on, just skip over that breakpoint. Or we can also go ahead and over here we see all the variables that we have. We're on line 26. So one of the variables we have is this cake variable. The cake variable being this little parameter that came in. We can actually see the sweetness scale of it. We can see all of its inner workings, its guts, basically. We can also see this EX right here, this exception. So basically, what you can do is go into the exception and see all the fun stuff. So we see, like, oh, look at this detailed message. Class chocolate cake cannot be cast to cheesecake, things like that. So it's giving you a lot of details there. So this is the main portion of the debugger. If I want to keep going, I would press that green arrow, and it comes up here, comes up to the system not out. And I keep pressing that green button, and it runs through. So I'm going to open up to you all. This is the basically the tip of the iceberg of the debugger, but it really does help to actually analyze line by line and see what your application is really thinking. Any specific examples that you would all want me to go into to dive a little deeper into it? Anything at all?
I was just gonna ask, can you kind of like go over that again?
Yeah, absolutely.
Awesome.
Yeah, let me go ahead. So we're in our application. Again, breakpoints can be set anywhere you want in the application. Do system.out.println here, starting up. So maybe myself, I just want to know, okay, after this line, did my chocolate cake variable get set up correctly? So I'm like, okay, let's go ahead and check that out. I'm gonna set a breakpoint right after it. It's gonna be a breakpoint right after the system.out.println line. Because what's gonna happen is line 11 is gonna run, and then it's gonna stop here on line 12. It will stop at line 12. It will not run line 12. It will stop at line 12. It will not run line 12. So right before it executes line 12, it will stop there. It's very, very important to remember that. Let's go ahead and try this out. What button do we click to start running debugger? Anybody?
Bug?
The bug, thank you.
The
Yes,
bug.
that bug icon. There we go. Yes, the debug program. I'm gonna click that bug.
By the way, line 16 has an extra C in front of the X.
Which line was it?
16 at the end.
16.
Oh, never mind. Never mind.
Okay. Yep. So that's one thing I wanted to call out. Name your exception something different. Don't all name them EX. That will, for scope, it will get confused. Yep. That's why you'll put like C or CC in front of it, whatever the acronym is.
So it just turns out I can't read line 15. All right, sounds good.
You're all good. You're all good. All right. So that's what we just saw here. We debugged it and it will stop right on line 12. But now I can actually go in and see the guts of my chocolate cake that was created on line 11. So now I can come in here. It's like, okay, my sweetness scale got to set to 7. Awesome, awesome. I believe maybe I can't specifically. Let's see. What else can we do? Oh, yeah, no. So we can kind of see the inner workings, our thought process of our application, what our variables values actually are. So that's what we did there. Once we're done with this line and we want to move on, we press this green arrow above it, resume program. And it would basically just run our application. So that is how we can set up a breakpoint, stop and analyze our variables, and then continue on. Now, one thing I want to show you here is that we can also walk through our application too. So let's go and rerun it. It's stopped on line 12. And maybe I'm like, okay, I don't want to set a breakpoint every single time. Let's go ahead and just step. Let's go and just step through everything. So now I can step over stuff, meaning I can move line by line. I can actually have the application run at my own speed. I'm like, okay, you want to do this, please pass me a cheesecake method. That's cool. If I'm at a method, I need to step into it. So it's the step into button. Once I do that, it moves me down here. Look at this. We actually see what line it runs each time. So it's like, okay, you got the cheesecake there. I'm going to step over, meaning I don't want to keep diving into my stuff. I just want to get my cheesecake and move on. And look what happened. It hit this catch. Now it goes back to this throw. I'm able to see exactly how my application is thinking to a T. There you go. I can keep clicking it and just see exactly what's going on. That is the beauty of a debugger. So there we go. And it hits that final one right there, and then it's done executing. See, I promised I was never lying. It does go sequentially, and now we actually get to see it in action. So any questions? What do the letters in the circles mean? Mark, which circles? Sorry.
When it stops at a breakpoint and it shows the variables, the top level one has a P in the little circle. You can just hit the debugger again.
This right here?
Yeah, P in front of args.
Oh, that, oh, what would the P be? Possibly public?
But then the other ones were F.
No, it's a parameter, parameter. P would be
Oh.
parameters. So it's a parameter. I can double check. I got him. You said what was the other letter?
If you open up chocolate cake, you'll see others.
Okay, let's go ahead and step over. So chocolate cake. I don't know.
Okay, never mind.
Yeah, I don't know. I think P would be parameter. F would be what would F be?
Freaking parameter.
Freaking parameter. That's what it is. Field. Yes, Robert. Awesome job. Yes, it would be field. Yes, yes.
Ah, field. Okay.
How do you choose step over versus step into when debugging? Step into is when you want to get into the methods. So we're right here at please pass me a cheesecake. If I want to actually go down and see please pass me a cheesecake run, I would step into it. If I could care less watching it run, I'd step over it. Stepping into goes into the method. Stepping over it means I just trust that the method's going to run properly. So if I stepped over this, it would not run, or I would not watch it run, and it'd just come and return stuff back. For loops, will it step over keeping the loop going? I believe you will have to watch that loop go, but let's go ahead and see if it does. For int I equals 0, I less than 10, I plus plus. That's print line I, there we go. Let's see what happens. I love your guys' questions because they're like, I've never thought of that. Let me see what happens, or I haven't seen that in a while. All right, we are at the debugging, so let's go ahead and step over that, step over that. Oh, nope, that's what I thought. It's gonna want you to do it 10 times. But what you can do to get around 1,000 loops is place a breakpoint right at the next executable line of code and just continue and resume the program. So you don't have to wait for it to loop 10 or 1,000,000 times. That's how you can get around that. Great question. Any others?
Can you do an example of an error and then debug it?
Yeah, absolutely. So we're at this, please pass me a cheese, or I guess to elaborate a little more, what kind of error are you looking for?
Doesn't really matter. Just something.
Okay. How about this, a handled error or an unhandled error?
Unhandled.
So unhandled, okay. So our handled ones would be in the catches. So we could have an unhandled one by saying, again, right here, this string, not a number, parsing one.
Yeah, that's what I meant.
Okay, cool. So let's go ahead and stop the program and re-debug it there. There we go, so we stop there. We're gonna hop, step over. I'm not gonna wait for that loop. So I'm gonna go ahead and resume. There we go, so we're at our string, not a number. We go and we're gonna step over, and then right here is where the error occurs. Again, we're paused there. Once I run this line, it's going to be a problem. It's going to output in my terminal, or wherever the build is. There, where are you? There you go. It's basically going to say that there was a problem. So we use the debugger to find exactly that line where the program terminates. That would be the best case for the debugger at that point.
Okay.
Is there anything specific or more in depth you wanted me to get into?
No.
Okay. All right. Any other questions then? Anything else? Anything anybody can think of? Throw it at me. Mark's got me stumped on the F1 today. Anybody? Anybody at all?
If we had put the break in line 17 instead of line 16, would it have been more illustrative of the error in logic, the error in the code?
So if we place it on 17, we'll be able to debug the exact same. We just won't have to click once. So it will still run because we pause here. We don't actually run the code, we'll just pause.
Right.
So the application will still go, right? So it depends on what you're specifically looking for. So the debugger is there to basically show you all the information that it has at that specific moment. So it depends what you're looking for exactly. So what would be the situation or any specific scenario that you'd want to go through? Okay.
It's basically just tools for error, for troubleshooting in this case, for debugging. Like I'm looking down in variables and I'm looking for, hey, where is string equals not a number? Where is my string equals not a number down in the variables down below? It should have assigned it because we've run 16. Oh, there we go. Okay, thank you.
Yep.
I hadn't seen you stopped on 12. Yeah.
Yeah. So basically, if I was the developer in this point and I was using the debugging, I would come down here, like, okay, I saw from my past that I'm getting this casting error. What the heck is actually going on? So I'd put a breakpoint at where my error was, line 17. I come down here and I'd see, okay, I'm about to parse int my string. What is my string? I come down here and I see it's not a number. I see it's a string, and I'm trying to parse an int. So my mind would be that, okay, I'm trying to parse an int out of a string that has the wrong, there's not a number in that string. So there's something wrong above it. Somebody's assigning this sentence to something that should be actually a number. So that's where my investigation would start. I know that the problem has to be above line 17. Somebody is assigning this sentence to the string that's supposed to be a number, and who's doing it? That's where the investigation would start. And as I see, look at that, the culprit's right next door, line 16. I don't know what I did there, but I shouldn't be assigning a sentence to something that's going to be parsed into an int. That's kind of what the debugger gives, is those certain little clues to get you to that answer. Great question.
And the idea
right.
of putting the breakpoint right where your error is also helps because you see everything up until that point.
Absolutely right. Yep.
Thank you.
You put, absolutely. Yep. Information, knowledge is power, right? Information is power. So yes. Cool. All right. Any final things? All right. If not, everyone, that is it. From the bottom of my heart, stick in there. You all are doing absolutely amazing. I'm happy to come here every single day and see you guys working through it. You guys are doing great. If you need any help, as always, reach out to me, reach out to your TFs, reach out to individual colleagues, set up a time to talk, or just talk about any kind of concepts that are problems. That being the case, that is all I have for you all